Binary basics. The easiest path to understanding zeros and ones. Base 10. Exponential form. If you've ever heard the word exponents and instantly felt anxious, you're definitely not alone. Exponents can seem intimidating at first, but here's the good news. If you've ever used multiplication while solving a math problem, you already have the basic skills you need to master exponents. Exponents are really just a shortcut for writing repeated multiplication, and we use them mainly to make big numbers easier to write, understand, and work with. To start our lesson on exponents, let's start with a concept you already know, which is addition. As a young kid, if you needed to add 2 plus 2 plus 2, you could count by twos and eventually arrive at 6. A rather easy task that most of us mastered early on. After mastering addition, most of us made the jump to multiplication. Now, instead of 2 plus 2 plus 2, you can simply say 3 groups of 2 and get to 6 in one step. So what is multiplication? Multiplication is just a shortcut for repeated addition. Instead of adding 2 3 separate times, you can just use multiplication. Now, exponents take that shortcut one step further. If multiplication is repeated addition, then exponents is repeated multiplication. Imagine you want to multiply 10 by itself 3 times. You could write 10 times 10 times 10, but that starts to get long as the numbers get bigger. Instead, we use exponents to express how many times we will multiply a number by itself. For example, 10 to the power of 3 means 10 times 10 times 10. This is written as 10 with a small 3 up above it, and it equals 1,000. Exponents are a convenient way to say, do this multiplication over and over this many times, giving you a way to write big calculations in a small, tidy way. Now let's look at 2 key terms, base and exponent. The base is the number being multiplied, and the exponent tells you how many times to multiply it by itself. In 10 to the power of 3, the 10 is the base, and the 3 is the exponent. You start with 10 and multiply it by itself a total of 3 times, which gives you 1,000. In fact, this is where the term base 10 comes from, because every place value in the base 10 numbering system is based on a power of 10. Let's break this down even further by looking at 2 special cases, 10 to the power of 0 and 10 to the power of 1. These show up all the time in place value and are key to understanding how exponents really work. Let's start with 10 to the power of 0. It might surprise you to learn that any number raised to the power of 0 equals 1. So 10 to the power of 0 is 1. This might seem strange at first, but it makes perfect sense when you look at how exponents relate to division. Every time you move one place to the right in a base 10 number, you divide by 10. If 10 to the power of 1 is 10, then dividing by 10 gives you 10 to the power of 0, which is 1. This is why the far right digit in any whole number is the ones place. Now, 10 to the power of 1 is much more straightforward. It just means one copy of a number, which in this case is simply 10. In fact, any number to the power of 1 is just the number itself. So here is the key idea about place value I want you to learn. Every time you move a place value to the left in base 10, you multiply by 10, making each position 10 times greater than the one before. But the opposite is also true. When you move a place value to the right in base 10, you divide by 10, making each place value worth 1/10 as much as the previous one. These special rules for exponents might seem simple, but they are super important. They help anchor the whole place value system and give us a consistent starting point as we move left or right. Now let's connect our study of exponents back to place value within the base 10 numbering system. As you move from right to left in a number, each column is worth 10 times more than the one before it. The ones place is 10 to the power of 0, which is 1. That's right, we start counting exponents at 0, not 1. This small detail might seem easy to skip over, but it's the key to understanding how place value is built. The tens place is 10 to the power of 1, which equals 10. Then comes the hundreds placed, 10 to the power of 2. After that, the thousands place is 10 to the power of 3. And the 10,000s place is 10 to the power of 4. Let's look at the number 70,273 as an example. The 3 is in the ones place, 10 to the power of 0. The 7 is in the tens place, 10 to the power of 1. The 2 is in the hundreds place, 10 to the power of 2. The 0 is in the thousands place, 10 to the power of 3. And the 7 is in the 10,000s place, 10 to the power of 4. Using this example, you can see how exponents give us a compact and powerful way to describe each place value in a number. Instead of writing ones, tens, or hundreds, we can write 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and so on. Once you spot the pattern, it makes place value easier to understand and gives you a solid foundation for working with even bigger numbers or switching to other number systems like binary, where the same structure applies. So when you see a number written in exponential form, don't panic. It's just showing how many times to multiply the base by itself to derive its place value. In base 10, exponents help us work with really large numbers and make sense of how the decimal number system is built. So far in this training course, you have seen how to read base 10 numbers in standard form, how to break them apart with expanded form, and how to describe their structure with exponential form. Now you are ready to take all of these ideas and apply them to base 2 or binary. These same principles of place value and exponents work in binary too, and once you see the connection, the world of zeros and ones will start to make a lot more sense. Thank you for watching. Subscribe for more great content.